Welcome back to video 4.4 of 4 videos. So we are almost done with chapter 4, and today we're going to talk very briefly about how to diagram an atom based on its Bohr model. And Bohr models have been a little bit disproven, but they're still probably the easiest way to visualize what an atom looks like. So we will refine our idea of an atom as we go through the next couple chapters. But remember, we started off with the idea that an atom was just this dense thing that couldn't be divided anymore. And then J.J. Thomson hypothesized that it wasn't just dense, it had electrons scattered throughout, sitting in something positive. And then Rutherford hypothesized that there was empty space, contradicting Aristotle, and that the positives were congregated in the nucleus in the middle, and the negative electrons were scattered throughout it. So Niels Bohr came up with the Bohr model, and it's called the planetary model. And basically it says protons and neutrons are in the middle. So you're going to look at the periodic table, figure out how many protons you've got, how many neutrons you've got, and that goes in your nucleus. And then your number of electrons. And specific energy levels can only hold specific number of electrons. So the first thing to remember is the first energy level holds 2, the second energy level can hold up to 8, and the third energy level can hold up to 10. For our purposes. It can actually hold up to 18, but for where we're going to go with 10. So, right here it says draw the Bohr model of hydrogen. So I look at the periodic table, and hydrogen has an atomic number of 1, and it has a mass number of 1. So that what that means is I have 1 proton, 1 electron, and since my number of neutrons is my mass number minus my atomic number, I do 1 minus 1 and get 0. So there are 0 neutrons right here. So what I'm going to do is in my nucleus, which is the gray part, I'm going to write that I have 1 proton. I'm going to write that I have no neutrons. And then I've got 1 electron. So that first energy level, that first ring can hold 1 electron. Excuse me, it can hold 2 electrons, but I've only got 1. So I'm going to draw my 1 electron right there. And that's the Bohr model for hydrogen. Now, if I were going to draw the Bohr model of nitrogen, so I find nitrogen on the periodic table, and nitrogen has an atomic number of 7. So that means it's got 7 protons, it's got 7 electrons, and then to figure out my number of neutrons, I'm going to do the mass number minus the atomic number. And when I look on the periodic table, nitrogen has a mass number of 14.01, so I'm going to go with 14. I've just rounded to the closest whole number. And the atomic number was 7, so that means I'm going to have 7 neutrons. So the way that I draw this is, remember, my nucleus is where my protons and my neutrons go. So I'm going to put 7 protons right here, 7 neutrons right here. And then now I've still got to draw my 7 electrons. Well, all of them can't go on that first ring because I can only have 2 there. So I'm going to put 1, 2, and now I've got 5 electrons that still need a home. Well, that second energy level can hold up to 8. Since I've only got 5, I'm going to start by going 1, 2, 3, 4, 5. If you noticed, I went the whole way around the circle and then went back and paired them up. So that's kind of how I'd like you to do that, starting on the second ring. And then last but not least, argon. So we're going to draw the Bohr model for argon. And argon, when you look at the periodic table, argon has an atomic number of 18. So that means it's got 18 protons, it's got 18 electrons. And to figure out its number of neutrons, we're going to do the the mass number minus the atomic number. So argon has a mass number of 39.95. So I'm going to round that to 40. And it's got an atomic number of 18, so it's got 22 neutrons. So I'm going to start off by my nucleus, 18 protons, 22 neutrons. And now I'm going to draw my 18 electrons. So the first two go right there. So now I've got 16 electrons left. And the next ring can hold 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And then I've got 8 electrons left. And my third ring can hold up to 10. So 1, 2, 3, 4, 5, 6, 7, 8. And that is how you draw the Bohr model of argon. So Bohr models are going to be something that will be really important going forward when we then further refine them into using the Aufbau and into talking about atomic emission spectra. So on the next couple slides, it's mainly a review. So remember that Democritus was the first guy to propose the existence of atoms. He said they were solid, homogeneous, and indivisible, but Aristotle did not believe him. Then John Dalton came along and proposed his theory based on numerous scientific experiments. The atom is the smallest particle of an element that retains the properties of that element. Electrons are -1, protons have a +1 charge, and neutrons have no charge. They are neutral. An atom is mostly empty space surrounding the nucleus. And remember that the atomic number is given by the number of protons. The mass number is the number of neutrons and protons. And the number of electrons is equal to the number of protons. And atoms of the same element with different numbers of neutrons are called isotopes. And that we can calculate the average atomic mass by doing a weighted average of all of the masses of naturally occurring isotopes. So thanks so much for your attention, and we are done with Chapter 4.